Good morning, chemistry students. Today I want to talk to you about calculating molarity. First, you'll need the molarity formula. Molarity, here shown as the italic capital M, is the moles of solute divided by liters of solution. Remember that a solution is made from a solvent and a solute. This can be simplified using these symbols. Italic capital M equals moles over liters. You'll use this when you want to solve for molarity. You can also rearrange this equation easily if you want to solve for other things. For example, if you need to solve for volume, you can rearrange the equation to say liters equals moles over molarity. Or if you need to solve for the moles of solute, you can rearrange the equation to say moles equals liters times molarity. Often when you're working on molarity problems, the units that are given are not moles and liters. So if you're not given moles and liters, you're going to need to do some conversions. First of all, often instead of giving liters, you're going to be given milliliters. So you need to remember that there are 1,000 milliliters in 1 liter. Or if you want to turn that around, you can say that 1 milliliter is equal to 0.001 liters. Okay, so for example, let's say that we have 250 milliliters of solution, and I'd like to know how many liters that is. So I'll make a small t-chart. I'll put in my known value, 250 milliliters, and I will multiply by this conversion factor. 1 liter equals 1,000 milliliters. I can cancel out my milliliters, and when I do so, I get that 250 milliliters is equal to 0.250 liters. Also, often the amount of solute is not given as moles, it's given as grams, and you need to convert using the molar mass. Now in your worksheet today, the author uses the term gram formula mass. That's just another way of saying molar mass, so don't worry about that. Okay, so for example, let's say you were given that you had 10 grams of solute and your solute was sodium hydroxide. Well, I would need to calculate the molar mass of sodium hydroxide. So I'm going to count up how many of each atom I have. I have 1 sodium. It has a molar mass of 22.99 grams per mole. I have 1 oxygen. It has a molar mass of 16 grams per mole. And I have 1 hydrogen, and it has a molar mass of 1.01 grams per mole. When I add that all up, I get that the molar mass of sodium hydroxide is 40 grams per mole. So I can input that here as the molar mass of sodium hydroxide. And when I cancel my units, grams cancel, okay, I replace with moles, and I get that I have 0.25 moles of sodium hydroxide. Okay, I'd like to show you a sample problem from your book. If you want to follow along, the problem can be found on page 465. It's problem number 15-3. And here's your problem statement. A 100.5 milliliter intravenous solution contains 5.10 grams of glucose, and the formula for glucose is C6H12O6. What is the molarity of this solution? Okay, so like with all other problems, I am going to write down what I know and what I don't know. I know that the mass of my solute is 5.10 grams of glucose. I know that the molar mass of glucose is 180.16 grams per mole. Now, if you don't believe that, you can certainly go and add it up yourself using your periodic table. It happens that the book gives this to you to save you time. It gives the volume of the solution as 100.5 milliliters. And what we're trying to solve for is the molarity. The first step is I want to convert the mass of my solute to moles. And I do that using my molar mass. 5.1 grams of glucose divided by the molar mass of glucose, 180.16 grams per mole. I get to cancel my grams, replace with moles, and I get that I have 0.0283 moles of glucose. The second step is I'm going to have to convert from milliliters to liters. Well, I know that I can multiply by the conversion factor that relates milliliters to liters. 100.5 milliliters divided by 1,000 milliliters gives me that I have 0.1005 liters of solution. Now I'm ready to do the last step, and that's to plug my values into my molarity formula. Remember, my molarity formula says that the molarity is equal to the moles of solute over liters of solution. All I have to do is plug my values in. I found that I had 0.0283 moles of glucose, that goes on the top, and 0.1005 liters of solution, that goes on the bottom. Plug that into my calculator and I get 0.282 molar solution.